Good morning. Welcome. I am Matthew Chan, the Vice President of Global Marketing for ACS Publications, which is a division of the American Chemical Society. I am actually based in Washington, D.C. The American Chemical Society is the world's largest scientific community. We have 150,000 members, 30 plus technical divisions. We have 185 local chapters and also 20 international science chapters as well. ACS on Campus, however, is one of our premier programs in which it is designed for outreach and engagement with the scientific community. It is the organization, the program is to provide tools and resources to researchers and students like you who are currently performing the latest research in chemistry. So today's session is all about you. We recognize that at this stage in your career, you face a lot of exciting choices. Whether you're thinking ahead about a career in industry, looking to advance in academia and publish your dissertation, starting to look at graduate programs, or even simply wondering what would you like to do with your chemistry degree. The goal of ACS on Campus and the American Chemical Society is to be your source for timely and relevant resources during your entire journey. So here's a brief overview of today's agenda to kind of help you along this journey. We will start with a session on 10 tips for scholarly publishing. Then we'll talk to you about the peer review process and an introductory guide. Then we'll take a little break to network and chat among each other. Then we'll come back and talk about communication skills and how that helps with collaboration in research and in industry. We'll wrap up by sharing with you more detailed resources about ACS on Campus, as well as, of course, giving us another opportunity to network during lunch. Now, before we start the program for today, I would like to thank Silvana Maggiancina from CNR, as well as Professor Maria Laura Bolognesi, Director of the Chemistry and Pharmaceutical Technologies degree program, for helping us organize and execute this ACS on Campus and for their continued partnership. Next, I also like to introduce our ACS staff who are here to help you answer any questions around ACS on Campus. We have Shayla Phillips, our Director of Global Conference and Events, sitting outside or right by the door, also helping with registration. We have Jessica Jang, who helps with our ACS on Campus program, as well as Sonia Gardadino, who is our account manager. Lastly, I would like to welcome and thank you to all of our ACS Journal editors who are here today. Again, we have Maria Laura Bolognesi, who is the Associate Editor of the Journal of the Medicinal Chemistry. We also have Massimo Morbidelli, who is the Executive Editor of the Industrial and Engineering Chemistry Research Journal. And finally, we have Paolo Fornasiero, who is the Executive Director of the ACS Catalysis Journal. So again, today we're here to help you, and we're looking forward to engaging you in a dialogue and answering all your questions. Feel free to share your perspective as well. Our X or Twitter account is up there if you'd like to also engage us that way. And now I'd like to kind of get the program started by welcoming Marco Caricato from the Department of Industrial Engineering at the University of Bologna, and Dr. Vittorio Morandi, President of CNR Bologna, to the stage.
So thank you very much, and good morning also from my side. It's a real pleasure to welcome here at the CNR of Bologna all of you and the colleagues of ACS on campus, actually. it's, I mean, the first time for CNR to host such an event. So today here in Bologna and tomorrow in Naples. So it's a real pleasure, and hope it's not the last time, but just the first one. I will also welcome all of you on behalf of CNR and of the research area of Bologna. Just to tell you a couple of numbers, a couple of figures, just to inform you where you are. Actually, this is one of the, I think, 3-4 largest and most important area of CNR in Italy. We are roughly 9,000 square meters of area, where are working 7 institutes of CNR, 2 institutes of the National Institute of Astrophysics. It's a pretty multidisciplinary area, actually, but with a big part related to chemistry and material science. Just to give you some figures, I would say roughly the 24% of people in this area are working in multidisciplinary chemistry, and another roughly 23-24% on material science. But then there is plenty of materials and chemistry also in the other topics that are covered, that are environmental science, atmospheric science, applied physics, and so on and so forth. The area has also several other institutions, I would say, infrastructure. One of them is the Biblioteca Dario Nobili, actually, that is pretty strongly involved in the organization of today. So let's thank Silvana for that, so Silvana Mangiaracina for that first. But we have also this large Congress Center that is serving several events internally and externally, an agency for the technology transfer that is a big part of activities of this area, and actually an infrastructure dedicated to that is called Technopolo, actually. If you're looking at the chemistry of this area, we have 2 main institutes working on that. One is the Institute for Organic Synthesis and Photoreactivity. There is Greta Varki here. I would like to thank her as well for the organization that is mainly working on photochemistry, synthetic chemistry, supermolecular chemistry, material science in several fields like health, environment, and energy, and also the Institute of Nanostructural Materials that is mainly in between, I would say, between chemistry and physics, but it's related to all the stuff related to nanomaterials for sustainable manufacturing, technology for cultural heritage, flexible and wearable electronics, energy sustainability, health, and also magnetic nanostructural materials. So that's to give you just an overview, but there is plenty of chemistry in all the other fields. I'm coming from an institute that is more related to technology, but there is plenty of chemistry there as well, but also in the environmental science, atmospheric science, and so on. So I will close here because I've been told that the time is short, and the real topics of today are others. Thanks once again. Thanks for University of Bologna, for co-organizing this event. Actually, as we will see in the next greetings, that this area will become a very powerful area for chemistry and material science, because on the other side of the border of the area, there will be all that part of University of Bologna, and also, again, the Biblioteca Dario Nobili and ISO for organizing everything. Thank you very much.
Good morning, ladies and gentlemen. I am Marco Caricato. I am the delegate in the University of Bologna for the PhD programs. I am bringing you the greetings of our rector, Professor Molari, and our vice rector for research, Professor Credi, who unfortunately could not be here since they are attending other institutional meetings that they could not miss. Special warm greetings, of course, goes to our prestigious guests of the American Chemical Society. And it's a true pleasure for me to be here in this campus, the Navile campus, which is indeed a district of excellence of the chemistry research in our country. This complex hosts 70,000 square meters of buildings with state-of-the-art chemistry laboratories, 3,700 students, 500 university teaching and administrative staff. There are 3 university departments in the chemistry fields: the Department of Chemistry, the Department of Industrial Chemistry, the Department of Pharmacy and Biotechnology. They form a strategic asset for the University of Bologna, which brings us excellent, impressive results that we are particularly proud of. The Department of Chemistry won for the second time the important funding reserved to the Departments of Excellence, and is definitely one of the leading departments in the chemistry field nationwide. The Department of Industrial Chemistry was one of the departments at a university that improved the most in the rankings of the National Assessment of Research Quality performed by our national agency for the evaluation of research in universities and research institutes. All three departments performed recruited in recent years research personnel of the highest quality, which for us is a guarantee of enduring excellence for scientific results in the year to come. In addition to the university settlement, as our colleague told us before, there is also a strong presence of the National Research Council. There are at least 3 institutes of CNR with a strong chemistry component. The Institute for Organic Synthesis and Photoreactivity, the Institute for the Study of Nanostructured Materials, the Institute for Microelectronics and Microsystems. The 2 institutions, the University of Bologna and the National Research Council, have a long history of successful collaboration, which recently led us to the establishment of an important research infrastructure called iEntrance, which received 80 million euros of funding for the National Recovery and Resilience Plan, a significant fraction of which will be devoted to this district, to the research that is performed here. So this campus, which sees the University of Bologna and the National Research Council actively collaborating in cutting-edge research, for us we believe has a sufficient critical mass to be a lasting engine of development for the research in the chemistry field nationwide. So thank you very much to the American Chemistry Society to be here, to be guests in this prestigious location. Thank you very much for attending this meeting and this workshop, and I wish you an excellent day and very great work. Thank you very much.
Now it's my turn. I would like to introduce myself. My name is Maria Laura Bolognesi. Many of you know me because I see many faces of my students belonging to the PhD of the University of Bologna, many colleagues. So I would like to start by thanking all the people who made this event possible. With Silvana, we started to reason about making ACS on campus before the pandemics. And we were so excited to bring the event in Bologna, and especially to do it together, because we know how important is the synergy between the University of Bologna and the CNR here in this context. But then the pandemic came and everything was stopped. So today, for me, it's a particular pleasure to be here. But in spite of that I'm so excited because of the event, today my task is not so easy. Because I'm supposed to give you 10 tips for scholarly publishing. And tips. So this means that after this talk, maybe you know a little bit better the scholarly publishing. And in spite of, I don't think there is a magic recipe, okay? I believe more than scholarly publishing is something that you learn by time. You learn by practicing, you learn by doing, by making error, correct errors and whatever. But what the American Chemical Society is doing, organizing these events for you, is because we don't want that you make very trivial errors. And it's very important to guide you a little bit into the process of scholarly publishing. So, but why should be myself to speak to you, okay? There is a reason, actually, because today I'm here as an associate editor of the Journal of Medicinal Chemistry. I'm not the editor-in-chief. I don't know if you know the organizational structure of a journal. There is an editor-in-chief that, in case of the Journal of Medicinal Chemistry, is a Professor Craig Linsley, based at the Vanderbilt University in the United States. And then to help the editor-in-chief dealing with the manuscript, there are a series of associate editors, and we are quite a lot at GemetChem, and I'm here, one of them, and I'm a medicinal chemist with basically 2 areas of research that are neglected tropical diseases and neurodegenerative diseases. Even to make a little bit of advertisement, very short, about my journal, which is the Journal of Medicinal Chemistry. I'm saying that because this is the most important journal in the field, and with a quite high impact factor considering medicinal chemistry. And also, as the name says, it is devoted to medicinal chemistry, but it is now medicinal chemistry is enlarging its horizon. So even you can find, for example, if you look a recent special issue, there is one of vaccine adjuvants or something at the interface of chemical biology dealing with covalent modulators and so on. And we are also very fast. So you can think, if you are working in the field of chemical biology, medicinal chemistry, you can even consider these for your publications. Okay, and next one. Also, I'm a particularly fond, I want to even to give you a little bit of a personal note, because maybe when you think about editors, you think of person, okay, maybe they are there, but an editor is always even an author and even a reviewer. So it is very involved in the scholarly publishing because of these many duties, because editors write papers, review papers, deals with papers, and maybe I'm here today because I'm standing from a privileged point of view, because I read many papers. I deal with 5 papers as an editor per week. And so that's why today I'm trying to give to you, to pass to you what I have learned being an editor at GemetChem since 2016. Again, there are no magic recipe, but I feel the responsibility to give you back what I have learned, especially from this privileged point of view. So the problem is difficult, yeah, because we are approaching scholarly publishing. Just a few words on scholarly publishing. This means that you want to disseminate your results, okay? And these results should go through the peer review process before being disseminated to the community, to the public, and the system of scholarly publishing means also that the results that your research have provided will be stored in a certain way into the journals. So it's so important. And it's not important just for you, no? For example, in our PhD program, we should, for example, have 2 published papers before defending the thesis. So it's very important to have papers, but this could be something very rewarding. For example, I love writing papers. It's very nice. And maybe because I have studied Liceo Classico, I don't know you if you like to write. In any case, It's very nice, especially when the paper is published, then your ego has a boost. Okay, I have a paper. But remember that you shouldn't see at this scholarly publishing as something personal, but what is very, very important, you are publishing your data because you want to contribute to the progress of science. This is the main issue. You want to contribute to progress your field. So if you consider that, you understand how important it is to make a proper publication. The problem is huge. So maybe when you have a huge problem, it could be easier to break into smaller pieces. So first, if you are going to write a manuscript, let's break the manuscript into the different components, okay? Trying to dissect the manuscript. That's why the first slide was anatomy of a manuscript, no? So let's dissect the manuscript into the different parts. The first one is the title. The second one is abstract and table of contents graphic, introduction, results and discussion, conclusion, references, supporting graphics, and experimental section. I'm sure that you are aware of these different parts, even if you have never written a paper, because you read the papers. So you have realized that these are the different parts. But these are listed, no, with this order. But these are not mean that when you write a paper, you should start from the title or from the introduction. This is something which is very personal. Maybe you can start even from result and discussion and then come back to introduction. I prefer to start from introduction. To me, it's more logical. But there is no a personal way. But in any case, something I would like to stress, don't put the references at the end. This is wrong. Because references are so important because you have to cite the work of other people, and you should do it at that moment. So even if the reference is at the end, don't work at the references at the end, but in parallel. And even the experimental section, don't make the error, okay, I'm writing the paper, but then the data are not okay, maybe I still miss an NMR, still miss a purity of the compound. No, you have to write the experimental section, so please have all of your data ready, because this is a very important part. I don't think there is a part to it that is more or less important, because even the conclusion, in the conclusion, you have to demonstrate that your initial hypothesis has been verified. So even the conclusion, which is a very short part, usually it's very important. So all of them are important, there is no order or whatever. So now let's try to discuss with you the 10 tips. Let's start with the first one. Create a useful outline. Okay, we are Italian, no? As I mentioned before that I attended the Liceo Classico, and when we write a thema, we are not used to prepare an outline, okay? Whereas this is very common in the English education, okay? But maybe writing an article, preparing an outline can help you. What is an outline? An outline is like a summary of what you are going to discuss in your paper. So this is a point that we have already discussed. First, you have to collect all the data, and then looking at the data, because science is based on data, on evidence, looking at the data, you should understand why and how you are advancing the field. Because again, the main trigger for a publication is not because you have to have 2 publications for the thesis, because you want to advance the field. And so others can build on your work to progress your discipline. Sorry if I repeat this, but I believe this is very, very crucial. And so you should understand advances. Then again, this is something even quite used. When you want to write an outline, you have challenge yourself with these 3 questions. Why, what, and how? Why I want to disseminate this data? And what kind of data I'm going to disseminate? And how? And even you have to organize the data, okay? You have collected the data, and you have to organize the data by importance and not by time. We know that many fields of chemistry are collaborative. So maybe when you collect data, you don't have the data all at the same moment because you rely on different collaborators. But when you look at the data, assured that they are organized by importance, no? First one, second one, listed in order of importance. Then put a lot of attention in writing the figures. First, to evaluate the need. Do I need a figure? Okay, you need the figures for many data, no? For plots, whatever, experiment, and so on. But maybe a figure is even important in the introduction. Maybe a figure can explain your rationale much better than a text, or even can complement the text to convey the right message. Something that is also very important, that again, writing a manuscript, yes, maybe it's the responsibility of the first author, but please, remember that it's always a collaborative work. And so it's not just yourself. You should, and it's very important to ask for the support of the others involved in the paper, not just your supervisor, but even all the co-authors. So if you write an outline, write in advance, and share it with your co-authors, they can give you a feedback that is very helpful to refine what you had in mind. And this is something you should consider. And don't do at the very end, okay? If you have a deadline, for example, the thesis, don't do all the process at the very end because it takes time. And so consider that. Second tip, you have to choose the journal, but choose the journal carefully. Today we are here with ACS, so we are talking about ACS journal. And let's focus on medicinal chemistry, because I know this field. So medicinal chemistry, ACS publishes different journals in medicinal chemistry. So why you should publish in Journal of Medicinal Chemistry or in this one, which is ACS Medicinal Chemistry Letters? Yes, this one. Why you should publish Journal of Medicinal Chemistry or ACS Medicinal Chemistry Letters? The two journals are different because ACS Medicinal Chemistry Letters just publish letters, and letters are not full article, okay? So in spite, the community is the same, the scope is the same, but they accept two different manuscript types. So if you have just synthesized not a long series of compounds, and the results are so promising that you want to publish them very quick, so as a letter, so go for ACS Medicinal Chemistry Letters. If your work is a long one, more complete, with a lot of SAR, so it's the so-called full article, please consider Journal of Medicinal Chemistry. So this is just an example to guide you into the great portfolio of journals. And you should be aware since the beginning the journal you want to choose. I believe this one is a very good point. Maybe why you should publish in Journal Medicinal Chemistry. Maybe you have read a paper in Journal Medicinal Chemistry dealing with the same topic you are dealing with. So this means that this paper has been already published. This means that Journal Medicinal Chemistry, the right audience for that kind of work, okay? And even now, if you are working at the within a European project, we are forced to publish in an open access mode, and maybe you want to focus on open access journal. But in any case, consider that there are so-called hybrid journals, some that publish everything in open access, and there are some so-called hybrid where there is simultaneously the possibility to publish in open access and also with the usual mode of subscription. This is something that I repeat to my students many times. Maybe I'm even a little bit boring saying that, but to me, this is the real trick. Read and follow the guidelines. Once you have selected the journal, you have to read the guidelines carefully. Why I'm saying that I become boring always repeating this? Because I know you millennials, because I have also a son of your age. So I know how you read. You are used to read very fast, not as we were used to do, no? We were reading books, long books, no? But you read very fast, you scan very quickly the text, okay? Because you have been grown like that, so you are a different generation, no way on that. But regarding the guidelines, please don't be scared that you have to read 3-4 pages, but at the end, you will get rewarded for that, okay? Because everything is written there, and I just want to give you an example regarding my journal, okay? In the author guidelines of the Journal Medicinal Chemist, at the very beginning, you see, we require purity of compounds to be more than 95% of purity. So this is so important, because if you have not characterized the purity of your compounds up to 95% of purity, this is not your target journal. And even you are losing time because you are submitting the paper, then the paper comes to the editor and the editor say, oh, you are not satisfying a basic requirement, a very important requirement of the journal. So please, in spite it could be long, please read the guidelines. And then, this is difficult, again, no magic recipe. A paper, with your paper, you should tell to the community a story. So, like you should write, not a novel, but you should be able to tell the others your story. And so what does this mean? Again, we can try to identify important steps in this process. And the first one is identify your main team, to have this very clear since the beginning. Explain why the problem is important. Okay, for example, if you are making new molecules, and you are making new molecules for Alzheimer's disease, is this important? Yes, it is very important, because there are, at the moment, no curative drugs for Alzheimer's disease, okay? So have this in mind. This is something that we should discuss this maybe hours and hours. Provide context to prior literature, okay? Because you are not alone, again. If you are there, it's because someone has made discoveries before you, and you first should know the literature. So again, this is my suggestion. Follow the literature, be informed on your topic, and when you write the paper, be able to contextualize your research within the previous literature. Another important point is that conclusions. We have already mentioned that conclusion should summarize your message. So in spite this is a short text, this is quite tricky to write, because you should support with the conclusion that you have fulfilled your initial hypothesis, and even stress the main advance. And then you should provide sufficient details in experimental for others. Okay, so don't be sloppy in writing the experimental part. This is something usually under your responsibility because you are the one who has made the experiment. Okay, the supervisors are responsible to check, but you are the one writing, compiling the experimental part. So please, when you report your NMR data, mass data, whatever, put a lot of care on that, okay? Because this is a very critical point at the moment. You have heard about that, I'm sure, that many of the published papers cannot be reproduced. So this means that even if you look at the experimental part, no, and you try to repeat the experiment, then the experiment failed. This is something which is completely against the scholarly publishing, because as we discussed at the beginning, you are writing a paper because you want to contribute to the advancement of science. And so the others should be able to repeat your experiment. So please draft the experimental part with particular care, because this is so important. The experiment should be rich in details. You don't have to write silly things, okay? You should write in a scientific language, but with all the details important to reproduce the experiment, and especially also because we are chemists. If there is an hazard, please remember to report the hazard so that the others can have a caution in repeating the experiment. Analyze the data thoroughly and objectively. Yes, we love our work. We love our results, so maybe we might tend even to oversell our results. So don't do this mistake. Don't try to oversell your results and try to be objective, okay? How many data you should include in your paper? The data essential to repeat the experiments, but maybe not too many. This is something to keep in mind, is also that not all of the data should be reported in the main text. Some of them can even go to the supporting information. So if you consider that it's important, there is something that you want to share, some data that you want to share because you believe they are important, but maybe they make difficult the paper to read, that you can just cite them and then put everything in the supporting information. And how should the language be? Yes, should be so-called scientific language. So, for example, avoid to use too many acronyms because maybe you are familiar with those acronyms, but someone else not. I'm not talking about DNA. Anyone knows what DNA, DMF is, but don't use a strange acronym, okay? And then always, because the language is so important when you want to tell a story, consider to use again a professional, careful language. Because maybe if you are not precise, if you are vague, then the impression that you can give to the reviewer, to the people reading your paper, to the editors, is not the right one. These are just some cases. Of course, they are stretched, they are exaggerated, but just to let you understand what we want to discuss. For example, if you write a sentence, "It has long been known," this is vague. What does this mean, "it has long been known"? Someone can criticize, say, that you did not look up the reference, okay? That you don't know the literature. This is bug. It's much better to make a reference to a specific previous paper or whatever. Again, in many cases, not twice. What does mean many cases? Okay, so these are examples of use of not precise scientific language. I would move to the next one because the others are similar. Draw graphics with care. Even this one is not trivial, takes a lot of time, and because the graphics to me are essential to help the reader to understand the story that you want to tell. Start very well in advance in preparing the graphics and be clear and precise. Again, don't be sloppy. Don't do at the very last moment. Take your time. Be professional, even in writing the graphics. Of course, this seems something that should not be emphasized, but of course, this is the first principle of ethics. Figures should contain real data, okay? But all of us, when we enter science, we understand the importance of ethics and even that in our everyday work, we should comply and stick to the ethical principle, okay? But this is a completely another story. But in any case, yes, figures should contain real data. Use the color. I see sometimes, even especially for table of contents graphics, that some authors send papers with talks with no color. Why? Graphics, by definition, should attract the attention. So always use color for your graphics, even when you are drawing structure. At the beginning, when I was doing my PhD, we never used colors to write the molecules. But now, if you want, for example, highlight a specific group into the molecule or something that you want to emphasize, use colors even for the structure, okay? Because they can help understandability. Then graphics must be original. I don't want again to spend time on that. And when you make graphics with your data, remember to always include the error, the statistic with how you have considered significance and so on. This is so important. We know. Here, as you can see in all the slides, are we providing the slides or not? I don't know. But in any case, yes. So if you see here these links, you can click on them, and there are specific publications or webinar on the topics. So if you want to maybe get more information on those topics, you can use the links that are listed in each slide. Please look at this picture and let me know if you like it, if you don't like it. Do you like it? No, it's too confusing. It's too confusing. There are too many panels. You don't understand where you have to start. Yes, there is A here, B, then there is another C here, but then it's C here, D. So confusing. And even, can you read here? This is a negative example, so don't do, even look how sloppy this looks, even in terms of resolution and so on. So, okay, this just to give you what you should not do it, okay? Talk. We have already mentioned the talk briefly because no, title and talk. Let's talk before about the title. The title. At the beginning, when we were discussing this at our editorial board in GEMET-CHEM, we considered the best title being informative in 10 words, okay? This is not something typical for us as Italians because we have such a rich language. When we want to say a concept, we use many words, but no, this is not the case for a title for a scientific publication. So maybe 10 words, it's very short, but if you can make a compelling title with 20 words, you are okay. So don't use a very long title, and the title should be grammatically sound. Yes, it's not easy to write in English because we are Italians, we know that. And so English is always the second language. And so it could happen that we can make errors, but please reread many times the title, because if there is a clear mistake in the title, it's a kind of like a business card, no? It's the first thing you notice in a manuscript. The editor see, the reviewer see. So being assured that there are no errors, and even don't use adjectives. So this is an error I was making at the beginning of my career because I liked a lot to use the word novel, okay? Because to me, to putting a novel in the title, novel class of so on, this means, oh, no one else has made this one, okay? But there is no reason to put this kind of adjective in the title, because if you are publishing them, this means that there is no prior literature, okay? So even try to avoid adjective, verbs, and something like that. Then the title and the talk, the table content graphics should be truly engaged, and the same word and concept should resonate, and avoid acronyms again, and avoid potential untested application and hard to justify claims. What does this mean? Let's make an example. If you have made a series of compounds for Alzheimer's disease, okay, but you have just tested them in a cellular model or an isolated proteins, don't sell your results by saying a new therapy for Alzheimer's disease, because you are not suggesting a therapy, okay? This means avoid potential untested application that to justify claims, okay? The talk, this is the most creative part. I love to thinking together with my students about talk, because there maybe it's less rigid or less professional. You can use your creativity. You can put even some figures, not standard, okay? But to get started, it's better to write sentences regarding the take-home message. And even, this is always a good suggestion. Look at the previous example. Look at papers. When you read the papers, look at the talk. Oh, and you say, if you have found a talk which is very nice to you, why don't save it? And you can even take inspiration. I'm not saying copying, you know, always say it first. But just to see a good example of how to make a talk. The color is very important, and even consider at looking at the requirements in terms of length and how the rectangle should be, whatever, and everything again is in the guidelines for authors. Be realistic, be creative, but also be realistic and professional, and use software to eliminate errors. Please even have always your language corrector in English, so even the typo could be corrected, okay? Avoid plagiarism. This is very important, but I don't want to talk about this one because this will take hours. But be aware that when you are submitting a manuscript, you are responsible of doing it in a proper way. So citing the previous references, don't taking entire part of a previous manuscript to write an introduction. This is something that you know, but it's always better to repeat. And especially avoid, maybe you know that this is something that you should not do it, but maybe you don't know that even you cannot copy yourself. If you have published a previous paper, don't use the same text even for writing the introduction and for even the experimental part, because we at ACS we use software for checking how much similarity there is between articles with respect to the previous one. This is something that we should discuss more, and even self-plagiarism, something that some is still under discussion if it's something that we can do or not. So I don't want to discuss about that, but please consider sometimes the paper can return to you because you have to modify even the experimental part because you had taken the experimental part from a previous your publication. So what I suggest to do, if you are using in your experiment maybe methods you have already developed, don't rewrite all the methods, but just cite the reference, okay? And this avoid this self-plagiarism. But the secret is also this one: revise, edit, and rework. So this guy here, who is a chemist from Harvard, in this webinar will explain to you that at least you have to write 20 versions of your manuscript before the final one. So this is, I believe, a very important suggestion. Prepare the supporting information with care. We have already mentioned that the support information, there is something that is not in the main text, but for example, in GMedChem, you put in the support information the HPLC traces, chromatograms of your compounds that demonstrate the 95% of purity. So this means that this part should be prepared with a lot of care. The traces should be good, not with a baseline, you know, which is not very stable or whatever. So even the supporting information should be written with a lot of care, even the spectra. If you don't like a spectrum, maybe because the resolution has not been very good, rework before preparing the support information. The last one, but not the less important. Write the cover letter. The cover letter, there is a tendency for the cover letter to copy the abstract, just to cut and copy the abstract, and write a cover letter by using the abstract. First, what is a cover letter? Why you are writing a cover letter? Because you want to demonstrate to the editor that your work is appropriate for that journal and it's relevant for that journal. So you should demonstrate that it's appropriate, that journal is the right audience for your work, and even that you are advancing the field. So you are writing to the editor, and this is the first document that an editor sees when looking at your paper. So don't make a trivial error. The first one, address the editor-in-chief directly by name. I want to tell you a story about that. Before Craig Linsley in GMedChem, we had two editors, Gunda Georg and Xiaomeng Wang. So there were authors just writing, dear editor. No, this was wrong because the editors were 2. So this meant that you don't even know who were the editors, okay? So before, this is a letter. When you write a letter to someone, you don't just write editor. You know the person you want to address, okay? Don't repeat the abstract, explain the appropriateness, the relevance, and be concise. Because even editors are very busy. Even editors are becoming like millennials, so they read very quick, and so be concise, and this is so important. Again, a lot of materials. We went into the 10 tips, but remember that there are additional key resources. Here are all the links, and I believe that there is a very rich portfolio of webinars, information, resources that you can visit and find a lot of information. With that, I believe that I'm ready for a lot of questions, and I would like first to thank you for your attention.
Actually, the question I had was that I couldn't see any, let's say, points on this presentation.
Could you repeat, please?
I couldn't see any points during your presentation dedicated to, let's say, how should we perform a part for the acknowledgement part of the paper, and if it is necessary at all or not. So that's basically the question.
No, of course, this is another part of the manuscript, but in the acknowledgement, you should be fair and professional, as usual, and ethical. Okay, so it's very easy if your PhD has been funded by an association or a project, whatever, you have to cite the funding. And even if during your work, this is something so important. So again, this will deserve further discussion. Even in the acknowledgement, you can acknowledge, for example, technicians who have helped you in making some experiments, even in interpreting the data, or even if you have discussed something with a colleague, should be mentioned there, in my opinion. Okay? So you are right. Maybe we should add another point related to the acknowledgement, because acknowledgements are very much related to ethical behavior. So I truly thank you for this question, which is actually a suggestion for us, because yes, this is something that should be considered with the same care as all the points we discussed before.
So I assume that the acknowledgement part of the paper also, let's say, is important in the opinion of the editor. I don't know if it is the case.
If the acknowledgements are important
in opinion of, if it is important in the opinion of the editor or not.
I mean, it's not the first thing that I'm looking, because even I should trust you, because I cannot say anything, but this is your responsibility. This should be you, with your ethical behavior, to make the right acknowledgement. Then this is something I cannot confute. What can I say? I trust you, because usually when you send a manuscript, I trust you.
Yeah. Thank you.
I would like to stay. I'm Paolo Fornasiero, executive editor of ACS Catalysis. I would like to stay on this very clever comment. I think it's very delicate, and to be honest, there is a way the editor may enter in the acknowledgements part in the revision process. It happens to me many times that co-authors are added during the reviewing process, after the revisions. And that's normal because the reviewers may ask for additional data. You do not have these facilities, so you involve colleagues to make new experiments. However, in some cases, this is very, very tricky. So I receive a revised manuscript with new names, and it's hard to see any explanation why these new names are added. And then, as an editor, I ask motivation. And of course, you can smile reading some of the motivation, graphics, literature search, and then someone is smarter, saying, yes, it's the same kind of experiment we did before, but the PhD left the group, and so we had to include a new one. And of course, in this case, you have to trust, but is quite delicate. And I think we have to look carefully at the acknowledgement.
Yeah, this is even matter of authorship. This is a kind of overlap between authorship and acknowledgement, but this, of course, this deserves a longer discussion.
Thank you for the insightful talk.
Thank you.
I have a small question. There is a habit that many people use cite or keep their citations in the supporting information. For example, they may keep the experimental part in the supporting information, the related citations they keep in the supporting document. So usually this will not be indexed anywhere. So the corresponding others will lose their credit. Do you have some comment on this?
Yeah, in GeometChem, this is not something very frequent because in GeometChem, all the steps for the synthesis of the compounds should be in the main text. So this means if you are repeating an experiment or reactions already published, this is in the main manuscript, so you are not losing the citation. I believe this is so important. So all the most relevant experimental part is in the main text. And so this is a way to try to skip this problem that you were citing.
Thank you so much for these useful tips. I have a curiosity, actually, because sometimes when you submit your paper, you are asked to propose some reviewers. And so I want to know which is the best way to do so, because sometimes you can focus on identifying reviewers who are, they know a lot of the topic, but also maybe you use some specific experimental conditions, so essays, where there are people that are more focused on that, but not, for example, on the specific target you are working on, and how all these suggestions are then considered by the editor. And
yeah, I would love to reply to your question, but we have a dedicated talk on that, so it's better not to spoil this. And then maybe at the end we can even complement this topic at the end, if you agree.
Thank you.
Sorry.
Thank you, Maria Laura, for
Grazie,
your talk. My question is about self-plagiarism. So you were talking about how you should be aware that you cannot repeat your text throughout your papers. And sometimes it can be difficult with experimental sections. When you do some kind of repeated analysis, when you apply your method to other contexts, it's difficult to change words. Maybe you can change some parameters. So that is sometimes hard to do. And people might think about resorting to some external help, like generative AI, to change the wording of your text. My question is about what is the ACS policy on the use of generative AI, which is a very hot topic right now?
Yeah, this is something that we have not yet discussed at GeometChem, so I'm following the situation, but still we have not discussed this in details. Have you done that? Because I know that is something possible. Maybe you want to...
Well, it's another very good point, questions. I would add self-plagiarism involves also PhD thesis, which is important. I recently had an experience of submission from a German colleague with 60% plagiarism with the thesis of the first author. And it started to be a problem because, of course, you have to declare and we check. So be aware of that. Putting the experimental part and the supported information, from my point of view, is not the solution, because I hate going to supported information back and forward, or just making references to previous work. So we have to try to rephrase, but it's difficult. So what is my personal opinion, and I think is shared in our journal, is that we must be open-mind editors. So we have the report, we see where the problems are. So if the problems really are only or mainly in the experimental part, we can, I'm saying, suggest to make minor changes. If the same plagiarism involves results and discussion, that's terrible. So there is no simple answer, but at least in my case, I know many editors that are really open-minded and understand that some experimental part is difficult to rephrase. Artificial intelligence is used, is under discussion. There are editorials. One also
there is one
signed by all the editor-in-chiefs, saying all the rules, and you have to declare that you have used. There is lots of debate, a nice paper, Nature Science, underline the fact that artificial intelligence, ChatGPT, has been added in the list of co-authors of papers. So it's really crazy, but ACS has this already in March, I think, in the spring this year, set all the rules, and responsibility at the end is yours as corresponding author. I mean, if the artificial intelligence is changing the references, it's your fault then if you have not checked. So there is a lot, and we should talk.
No, maybe, sorry if I interrupt you, because you have to move on to the next speaker. I was not replying. I know in GEMET-Chem we follow the same rules that he's saying about looking if it's an experimental part or not. We have not discussed yet about ChatGPT, not that we have not discussed. I don't want to convey the wrong message. I know that there is an editorial, and I have read the editorial, but I believe that this is something that should be discussed and even put in the author guidelines, and then to make it clear to the authors, just referring to ChatGPT or AI for rephrasing. Thank you, thank you.
So good morning, everybody. My name is Massimo Morbidelli. I'm Emeritus Professor from ETH Zurich and Emeritus Professor from Politecnico di Milano. So Emeritus in Italian sounds like good, right? Somebody who has done something good. Actually, Emeritus means only very old. So it's not great, right? So old that I had to retire. So that is the meaning of Emeritus. But here I am in my role of the executive editor, and we will discuss what the executive editor actually is. And for the journal, ACS Journal Industrial Engineering Chemistry Research. So in fact, here we are touching one of the extreme of chemistry, which goes towards applications. And so my mind is towards applications, towards the applied part of chemistry, to industrial chemistry. And I have to confess, I'm a chemical engineer. I'm not even a chemist. So we move to what happens to your manuscript after that you have prepared it, right? So Maria Laura was gave a very nice talk. I learned some things, how to write a manuscript. Unfortunately, it's almost too late, right? But nevertheless, is useful. So here we want to go through what happened to the manuscript, which is the peer review process. So peer review. So the real question here is how to evaluate a paper. All right. If you think a little bit in our society, we go with democracy, right? We ask a question, then we vote, we count the number of yes, the number of no, and then we decide what the correct answer to the question was. In science, doesn't work. Science is not democratic. Sorry, this is the fact. Example, Galileo Galilei, right? He was the only one against everybody else. He was right, all the others were wrong. So science is not democratic. So how do we go about evaluating a piece of science, which is a paper? Well, that is the criteria, the peer review. So you have to expose your work, your ideas, your results to your peers, right? To your peers. This is a very important, very interesting word. So all together, your peers have the right and the duty to evaluate your research. So this is where a piece of science is evaluated, through the peers. Now, I use the word evaluated, but it's not only that. This is not only evaluation which will occur here. This is also getting the support of your peers in improving your paper. And this is something you have to keep in mind. As many times we see as editors that immediately goes like a little battle, between the author and the reviewer. They kind of, the reviewer is trying to kill the author is trying to counter back and not be killed. This is not the right way to do it. There is a contribution, actually. It's a cooperation to improve the paper. So this system of peer review is not only evaluation, it is also collaboration to improve. And there is also another aspect in the peer review, which is very important in science, which is recognition. Now, we have, as scientists, we have to recognize, we have to give credit to our colleagues who have done something before us. And that's very important in the references system, not only to, like we have said before, shorten, don't repeat things which have already been written somewhere, but also to give proper recognition to our colleagues who have achieved something. This is one more very important aspect of the peer review. So this is the summary is summarized here, which I think is very important. And then we can move on to understand why is this peer review system important. So what I want to do is to describe it a little bit, as I did in general terms, and then we'll enter the details of how this peer review system works in ACS journals, but actually in all journals that are out. So first is to determine the relevance and suitability of a paper, right? We don't want to flood the journals and with a lot of information which are not suitable, not relevant for what we are doing. We have to preserve integrity, and this comes also with the recognition, credit recognition I mentioned before. The peer review system will allow the author and the reviewer to be in touch, to share their information, and this is where being a peer is important, because those who are evaluating your papers are scientists just like you, doing basically the same kind of job you are doing, and there is a possibility for both to benefit of this. And this is a key issue. We have to regard this process of the peer review as a way to collaborate with a person who is anonymous. You don't know him, right? He knows you. You don't know him or her. But this is just a little bit more spicy, but is not changing the substance, right? In addition, it gives the possibility to the reviewer to be very open, right? Some of them become even very bold, right? And sometimes even aggressive. But this is not bad, this is science at the end. You just cancel everything, all the adjectives that you don't like, and just look at the message that you are giving, if you are an author. So if you're an author, you just learn from your reviewer what he says. You don't try not to be upset if he uses some bad word. Who cares, right? You just look at the science. If you are the reviewer, on the other hand, then it's good that you try to provide all the help you can to the author without insulting him, right? You don't want to kill him. He's just a human being like you. I mean, there is no major difference. It's just that in that moment, you happen to be the reviewer. Next time, it will be the other way around. So both reviewer and authors benefit from this. The reviewer can see your work before it's published. You should not take advantage of this in a wrong way, of course, but this is an ethical issue. But this is interesting from a scientific point of view. Well, peer reviews means also to keep high standard, right? We don't want, as I said, to flood the literature with a lot of information or papers which are not really relevant. Pay it forward. This is there to indicate that we are a community, which is very interesting because each one of us can be a reviewer or an author, and we actually are, right, in our life, everyday life, sometimes acting as a reviewer, sometimes acting as author. So we have to serve, not only to take advantage of the service of the reviewers when you are an author, but you also have to serve as a reviewer where your colleagues, where your peers, the word comes back again, when your peers need you as a reviewer. And you have to think, you see, in your, when you receive reviews of your papers, is like, what, 3, 2, 4 reviews per time for each of your papers? There is no complex math, you know. This means that the number of reviewers have to be 3, 4 times larger than the number of authors, right? Otherwise it doesn't work. So that's why you have to be open to review papers. Of course, if they are not close to your science, then you can reject them. But when you're asked to review, you have to, if you are in the position, if you think you can contribute, but maybe you are a bit short in time, okay, take your time, but do it. This is a service you have to provide to the community, because the time when you be an author and submit the paper, you will expect somebody, some of your peer, to come up and give you time, their time to review your paper, right? So we have to do this. I'm saying this because, again, as editors, we see sometimes you have to suggest 10, 15 reviewers before coming up with 3. Why? Because all the others do not respond, reject, saying they are busy, right? So this is not correct, and this is also unprofessional, and I would say almost unethical, because you cannot deny your service when you're asking to your peers, when you're asking them to provide the same service to you, right? So this is an ethical issue. So these are the steps. So this is what happened to your paper. This is what Maria Laura very nicely told us before, that you do and then you submit. And once the paper is gone, so in my days I used to put in a nice envelope per email, right? Not email, yeah, per airmail. So I cannot even say it right. Now instead you push the button, and then what happened is that first is the press screen. So the press screen is done by the editorial office, so it's not necessarily a scientist involved in this, although in those offices many times there are excellent scientists, but this is not what they are looking at. So here is that everything has to complain with what is in the journal guidelines. So this is why Maria told you, read the guidelines. If you don't read properly the guidelines and send a paper which does not complain with the guidelines, for example, is too long, right? Longer than what the journal asks, or with purity, Maria Laura mentioned before, below 95% of some compounds, then the paper will go back to you at this level, which is very bad. You're wasting everybody's time. So don't do it. After the press screen, we go to the EIC, this means editor-in-chief, review, and then the associate editor review. And so this is what is called the editorial review, these two panel together, right? The executive editors, like me, right, are not here, right, because they actually serve for the editor-in-chief. And they typically, at least for our journal, we have that at this press screen level, it is decided which papers go to the editor-in-chief, which one goes to the executive editors. Anyway, both of them do the same thing. They look at the paper, typically at the abstract and the title very much, the abstract, they try to get a feel. and try to decide in 3 different directions. One is to reject it. This means that the paper is really typically out of scope, right, of the journal, nothing to do with the journal, or is clearly doing something which is not interesting, as too old. For example, I remember when I started, they told me the typical example was if one submit a paper of ammonia synthesis, you say, no, we know how to make ammonia, right? This is over. And now it's that things are going back, because there's a lot of work making ammonia for transportation as a green fuel and everything. So things change, but typically this must be some very, very strong reason for the editorial at the executive or editor-in-chief level to reject the paper. Another possibility is to transfer. So if the paper is not proper for that journal, this is what we use quite a bit. But in many cases, we go for the advance. The advance means passing this to the associate editor. So one can ask, why do you want to have all these stages? Because there is a difference here, which is the associate editors are maybe 20 for a journal. So the editor-in-chief has to decide which one is the most appropriate associate editor for a given paper. So at this level already there is a improvement in the quality, in the scientific knowledge specific to your paper that is requested to the editor to evaluate the paper. So another important aspect is that if there is, again, some very major problem with the paper, for example, is not submitted to the right journal, then the reject or the transfer options come to you immediately. You don't have to wait all the thing to go down to until the peer review. And the peer review is something that, or the reviewer, the peer reviewers, is something that we have to touch with cautions, right? As editors, our reviewers are very, very important. So we don't want to flood them with the papers that they don't want to read. So one of the things that I really hate having back from my reviewers when they say, this is the worst paper I ever read in my life, which happens, right? So this means I should have thought about it and canceled the paper before sending it to him, right? So we have to respect our reviewers. Remember, they have to be at least 3 times more than the authors. So they have to be many, and they have to be expert. So you cannot just use them continuously. We have to respect the number of times that we can ask them to review. So anyway, after this, let me say, very high-level editorial review by the editor-in-chief, we go to the associate editor reviewers, and they are the ones who decide the reviewers. And so they will select the reviewers and send the paper to this reviewer here. Here, this is where the hard job of finding the appropriate reviewers is. This is where we see that probably you have to propose 10 reviewers to find 3 who accept. This is more or less, I don't know in the experience of the others, but this is more or less the ratio we have to go, which means that, for example, in order to cut the time for publication, I cannot ask 3 reviewers, wait the response, and if they don't all accept, ask 3 more or 2 more, and then wait the response. This will take forever, right? So what I do, I send it to 10 reviewers. So I bother 10 different people, right? Because I know that only 3 of them, in average, will respond. And in order not to increase the time for publication that you authors like to have short, then we have to do this. But if you, as an author, when are asked to review, respond immediately yes, then maybe we will learn not to send it to 10, but to 5. And so you will have short publication time, which is good, and we will not be flooding the reviewer. So this is why I insist that your job is not to be an author, not only to be an author, is to be part of the peer scientist community, which implies be an author and a reviewer. And the 2 things go hand in hand, cannot be separated. Good, so then the reviewer write their opinion, and then the associate editor will take a decision. It will not go back to the chief editor. Right? So this is that the final decision is taken by the associate editor, who can accept the paper, can transfer to another journal, or can ask to revise if something still is not in order. But eventually, they will have to accept, transfer, or of course, reject. So the review integrity, this is very, very important. So there are some major, how can I say, breaches of integrity, which are almost a crime, right? Today it's happened, it's incredible, but this happens. So there are authors which are very, very clever, or they believe they are clever. They create a separate email account, and they suggest themselves as reviewers. So they get their own paper to review, and they very happily say, this is a very good paper, right? This is obviously a crime, right? This cannot be done. If you're catch doing this kind of things, you can harm your career, for many, many years. So definitely don't do this. Or ask someone to complete a review, and then you use that under your name. This is also not fair. The editor should know your name. The author should not know your name anyways. So the good thing is that if you are asked to review, you do the review with your name. Don't ask somebody else to do it. Now, if you're an old professor, like me, then it's possible you have students, right? Your PhD students. Then I think for professors here is very good practice to ask your student to do the review. Let them do it, so they practice, they learn how to do it. And then once they have done it, you look at it yourself, and so you correct if necessary, whatever has to be corrected, which is the right service to the author. And then we can add another thing, which is write to the editor that this review was done by your student so-and-so, and you feel the reviewer was very well done, of course, if that is the case, and propose the student to become a reviewer, independent reviewer to the journal. That will make a third service to the community, which is to provide the editors with new potential reviewers, which is a need we definitely have. Reviewer reveals identity to author without editor's prior approval. You can do everything. You can ask the editor to do everything you like, but don't do it without asking the editor. So you can ask the editor, well, I would like, for whatever reason, the author to know that this is me. Why not? If you have a good reason, explain it, right, to the editor, and the editor will tell you if it is a good reason. Of course, do it. But you should not, absolutely not do it without asking the reviewer. Then the last one here, well, the one before the last one, this is also very important, that you should not take should not make any use of what you learn from a colleague paper to your own benefit. You should not go quickly in the lab, do the experiment, and publish before him. That's not acceptable, right? So you should really look at the paper from a very objective way and don't touch it before it's published. Okay, you can, of course, prepare yourself. You say, this author had a very good idea. I approve it. And now, reading this, I got another idea. There's nothing wrong in thinking about it. And when the paper will be out, you finish your own work, which is related to that. You make proper reference to your colleague and acknowledge that he has done this and that. And then you did something else. Fine. This is perfectly okay, right? But not doing it before this is published. And then, of course, if there is a conflict of interest, for example, if the paper comes from a colleague of yours or former students or things alike, you should inform the editor about it because there is a potential conflict of interest. It's very possible that the editor tells you, okay, fine, he's your former student, still I want to see your opinion on the paper, right? Or he may say, okay, fine, then it's a conflict of interest, I don't want to. But important is to communicate it to the editor. Now we want to go a little bit more into the details about this pre-screening and editorial review, and then we will go to the associate editor level. So here is the importance of this. This is what largely I told you already. So we have to check at both the press screening, which is the editorial office, and the editor-in-chief or the executive editor. They have to check against requirements of the journals and the ethical standards. We already discussed this. The idea is to avoid to overburning the system and that therefore to identify the best reviewers. And this kind of make sure not to overload the reviewers. Also at the end has the result of shortening the time for publication, which is what interests not really the reviewers, but more the authors, right? So this pre-screening that is made here has these two results, which are equally important. And then, of course, match, and always ensure that we allow only papers which really have the qualification to appear, to be made available to everybody to appear in the literature. We have also to make sure that the literature cannot or should not be overflowed with information which are not novel or inappropriate or maybe even wrong. This is obviously not good. So this is what the editorial office pre-screen does. So confirm all journal requirements are submitted and readable. These are the things that Maria Laura mentioned that you have to read to the guide, in the guide of the journals. For example, the length is one of the things which is important. Plagiarism, this is done maybe at this level or maybe on a second level, but is always done. And then maybe, I don't think we do a lot of this data check, but some of that is also done. Now, plagiarism is a very important aspect, but I think we have to use it with a common sense. We as a scientist have no interest to publish things which are already available, right? If something is already written down somewhere, there is no reason to write it again. So therefore, use references. Instead of rewriting, use references. Of course, if you have to give a message of 2 lines, which are already published somewhere, like the temperature and the pH of a certain analysis that you have done for a paper, you don't want to send the poor reader back to the journal and another journal come back in order to know the pH, and you may write it there, right? So for the question before also, if there is a need to repeat a few sentences, something in the material preparation or experimental section, there is nothing wrong with it. What will appear to the reviewer, to the editor, is that there is a copy and paste done with respect to this paper number so-and-so, with the author so-and-so, but is maybe 1%, 2%. And that is not a problem, right? No editor will. Of course, in the old days, we were writing everything on paper. We were much more serious about it, because the matter was to save the paper. But now it's electronic, so it's not so crucial. So 1-2% repetition is not a problem by any editor. Cannot be called plagiarism, right? But of course, if you repeat 50% of the paper, then it doesn't work. This is a relevant issue. When you see the plagiarism report, is impressive. Any paper is probably has probably plagiarism or superimposition with at least 20, 30 other papers to a level which is in the order of 1-2%. It's incredible because at the end the number of words we use is not that many, right? So sooner or later you repeat, even without willing, things which have already been written. So that is not to be taken so strictly. So this is like we said, the slide which explain again what I already mentioned before, the concept of 2-stage editorial review. Why we need these 2 stages? One at the level of the editor-in-chief or the executive editor, and one at the level of the associate editors, which are selected by the editor-in-chief. So I think we don't need to repeat this. And these are the factors that typically the editors considers, right? Does the manuscript fit the scope of the journal? And this is why we have to check the guidelines. We already discussed this. Does the manuscript meet the scientific merit, which means that there is a true advances in science? And this is obviously what the reviewers and the associate editors will have to worry about. And then, very important, the novelty. The novelty, which also is related to what I told you before. which is the give proper credit to the people, to the scientists who discovered some things or some concept, some data first, right? This has to be part of our job as scientists. Now, how do we select the peer reviewers? And so I told you it's very important that you, as a young scientist entering the community, think to act as authors, because this is important. You want to be an author and have many good papers out, but you have to be also a reviewer. There is some advantage in doing this, but also you do this because of serving the community. So the editors typically have three ways of selecting reviewers. One is the pool of experts, which typically comes in ACS, for example, by a software which gives suggestions about reviewers. Then there is author recommendation, and then there is the editor network. So people that the editor happens to know, being expert in some paper. But what I want to focus here is the author recommendations, right? You are asked to suggest reviewers, potential reviewers. To be very honest with you, I understand that there is the temptation to put the name of a good friend, right? And then he will give you a good review. The problem is this doesn't work. Because the good friend typically will say, wonderful paper, the best paper I've seen in my life, accept it as it is. And editor takes this and throw it away. There is no content, all right? So your friend will have to take an effort to criticize something, right? To find some meat into this. But this I see does not happen many, many times. Best is that you make an effort to get the topic, the top people expert in what you're doing. Maybe in the experimental part, there was a question on this, or maybe in the theoretical part, maybe some of the analytics which has been done, maybe in something that you are a bit afraid of. Why? Because an expert can give you a good suggestion. So you should not regard this point here of suggesting reviewers as a way to, try to get some way to go around the review process and get your paper accepted. That's not your goal. Your goal is to have in the literature good work under your name. You want your name to be associated only with papers of top level. So suppose that you make it through and you get, you give your email address as a reviewer and you get it to review your own paper, then you ask 3 friends and all of that, all together get it through. And then you have a nice paper with your name with an error inside. And somebody write a paper and say, hey, this guy is stupid, this is an error in his paper. Is that good? No, it's bad, very bad. So you use the reviewer moment to have the possibility, the opportunity to have your paper, being a young scientist, reviewed by maybe the best or one of the top scientists in this area. If you go there and ask him to do it as a consultant, you will have to pay a lot of money. Here you do it for free. Wow. Isn't that great? So this is the moment where you have to submit, to select in the authors recommended, the persons who are the best. And we see many times. So, for example, you can detect this by geographical similarity. So get an author coming from country A, and then he suggests 5 suggested reviewers, which are all coming from country A. And country A is not known to be so spectacularly strong in that specific field. So why? Because the guy is trying to suggest people he knows, right? Rather than going around to look for. So this is also very bad. And in addition, I have to tell you that, I don't know if this is typical for science, or it's true for all the people, but I see many, many times authors suggesting reviewers because they are friends, and the friend killing the author, killing the paper, right? And of course, once you see that the reviewer suggested by the author is very negative, I mean, what else? You kill the paper, right? There is no way out. Even the people he suggests as the expert say this is not a good paper, then game over. So also, I don't want you to not to trust your friends, but maybe for other reasons, not for as reviewers. So this is what we like to see in the peer reviewers. So broad knowledge and understanding of the field, of course, technical expertise in evaluating data, experiments, and models, the ability to offer constructive and fair and unbiased reviewers. So this is also a very important thing. If you dedicate a bit of time and you get good reviewers, we have also prizes in the ACS, at least we have it in Industrial Engineering Chemistry Research Journal. I suppose this is common practice in other journals, also to give a prize, to give a mention, to give a certificate to the top reviewers, which is nice to have. It shows that you are a responsible member of your community, which is very, very, very important. And then there is one more point here, that in case you are really not able to accept because you have no time to review a paper, well, why don't suggesting a colleague? Or for example, you are an old professor, then what about your students who are maybe working in some other university? They like to start being more and more recognized as reviewers, so can be a reviewer. So suggest those guys and help the editor to find reviewers and help the machine running, right? This is the reviewer perspective. So how do I get invited to review? Now, of course, if you do your job properly, sooner or later someone will notice you. So publish, do good work, be online, people will recognize you. But I like to here mention two things. First, the training course by the ACS Reviewer Lab, which I've seen. These are very, very good to train you. But then you don't have to be shy. Like I said, this is a service for the community. So you have to even qualify yourself. There's nothing wrong in writing to an editor and saying, okay, I am so-and-so, I got a PhD in this, and now I am working for this company, or I'm working for this university, my research field in this, and I will be happy to review for your journal. You can do that. There's nothing wrong. Write directly to the editor. He will be so happy to add you, to check your credentials, of course, and then add you to the reviewer community. And the way to answer to this is when the editor will come back to you and select you as a reviewer, then you do your job the best you can. And of course, you cannot dedicate a week on a paper, but a few hours, certainly you can and you must. So this is the anatomy of a good reviewer, I don't know. So when you make a good review, you have to summarize the research findings, contextualize and cite the research field. This is to check if there is novelty in the paper. Here is one distinct problem, that is that in order to increase your citations, or their own citations, sometimes reviewers insert their own papers they ask their own papers to be referred to in the manuscript. This is not ethical. You can always try to do this, but if you're catch, you go real down the tubes. The editor will dislike this, and you will be certainly receive some bad comments, which can hurt your career. Of course, you are a reviewer, you've been selected as a reviewer. It's very possible that you have done work which is not referred to in that paper, which will be interesting for the author. Fine, then you refer to your paper. Nothing wrong with it. There is nothing wrong a priori, as long as we remain ethical and serve science. But if you come up with 10 papers of yours and you ask the author to refer to those 10 papers, not really related to the paper, then it's clear you're doing something completely wrong. So scientific merit, of course, is what we have to check. Then you have to check the data quality, comment on the presentation. For example, if you think that the figures are not well done, this is a good time to mention this and ask the reviewer to change this. Finally, is the recommendation. Recommendation is this minor and major, right? The idea is minor is something that you think can be fixed in very short time. Major is, and at the end, if the author does not agree, you leave him to decide if doing that change or not. Major means that you believe that if the author does not change this, cannot be published. Okay, so this is the major difference between these two, minor and major, not necessarily related to the effort which is needed to make the change, but minor means that you leave it to the author to do it. eventually at the end, major means that in your opinion, this has to be done, because otherwise a big problem. This is another aspect which is also relevant, which is you see that as a reviewer, you always have the possibility to talk to the authors and the editor, and also talk to the editor alone. The author don't see this. So you can use the space for delicate issues like conflict of interest, the request for additional references, like, for example, the one to yourself, which you don't want to say explicitly because you don't want to reveal your name to the author, or, for example, that you have seen this paper already from other, submitted from other journals. This is also an important aspect. There is always a bar or a box to be checked, asking if you have submitted that journal to another paper. Now, not doing this, if it is not true, is not a good idea, because the reviewers many times are the same. So the reviewer will tell the editor, hey, I've seen this paper already, and I gave him reject, and it was rejected. Now you do what you want. And the editor has, received the message, so he's immediately inclined to reject the paper. So if you have done it, submit it, write it down. Basically, never lie. Never lie. For whatever reason in this process, you never lie and think about science. Be open. If you are not sure, ask the editor. Everything is allowed if you ask the editor in good faith. Now, well, this is an obvious thing. Some reviewers like to tell the editor this paper is very, very bad. You just kill it and cancel it, and then to the author they say, "Oh, very nice paper. That's very interesting." And then, of course, the editor has a problem, right? And this is the author perspective of this way. So the question is how the editors make a decision. They read the paper, or anyway, examine the paper, analyze each of the review, determine if, based on the review, there is some additional work needed, and then decide where to go, to accept, revise, transfer, or reject. Now the question is, this is how the editor looks at it. Now the question is, when you as an author receive the editor letter with all the reviews, how do you act? Well, next slide shows you is exactly the same. So you examine all the reviews very carefully, then understand the feedback and the relative importance to each point, and then you have to determine if additional work is needed, and if it is needed, you do it. If it is not, you don't do it, right? And then you provide a response to the journal. These are the things that you should not do as an author. The first one is to answer immediately. And typically, you get a review which is not so positive, you get mad and you write a mad letter back. Wrong. So first thing, if you want to write the letter, is very good, you write the letter if you are mad, but then don't send it. Just throw it away, go home, sleep, talk to your friends, and the next day start all over again, right? These are the things that you should not do, which is ignoring the reviewer's comment, not paying attention to the editor's comment, ignore the priority in suggested improvements, and not having maybe a colleague reviewing your paper. And this is maybe even more clearly indicating what you should not do as an author response to the editor letter with the reviews, right? What should not do is start insulting the reviewer or trying to say that the reviewer does not understand nothing, right? Because number one, the reviewer may be one of those that you suggested. And the editor said, well, this guy doesn't know what he's talking about. He suggests me this reviewer, and then he said, does not understand nothing. So. Second is that the editor immediately thinks, if this reviewer, who I think is an expert in the area, has not understood the paper, means that even if there is something good to be understood there, be communicated there, but it's not understandable, it's not clear, right? So it has to be rewritten. So this is a very important concept, that the reviewer, attacking the reviewer never pays off, right? Instead, what you have to do is to be very cool, very cold. If the reviewer has some strong statement, ignore them. Just take his science, what are the scientific points he mentioned, and respond strictly to that with no emotion. For us Italian, it's not always easy. That's why I say write the letter, write all the insults you want, but then don't send that letter. See, the reviewer is wrong, and I am not going to explain. This is a possible answer, and the editor will understand the author must use science to explain why reviewer is wrong. This is another typical excuse given, which is that student left, I cannot do. So the reviewer asks you to make some more experiments, and you say, well, the student left, I don't have anybody to complete this work. You have to think that the scope of the paper is not that the author has one more paper, right? But it is that you communicate to the world some piece of science which is new and help us to advance knowledge. So if the reviewer thinks that there's some more data needed, you cannot say, I have no time to do it. The editor will always answer, well, take your time, do it. But without that, I will not publish it, right? Similarly, is when you say that the editor says, well, this paper is not suitable for the scope of our journal. Well, if you answer, this is sometimes, well, similar research has been described in the journal, then it will understand that maybe your science is not so novel if similar research has been already published there, right? So it's better that instead, for example, you refer to your reference list. This is what Maria Laura said very, very well before. If it is very unlikely that you are going to publish your paper on a journal which never appears with your list of references, right? That means that you are the first guy working in that area applying to that journal. Something smells wrong. And similarly to the editor, you can say, look, I have referred to 10 papers in your journal. So it means that the correlation with my research and your journal is clear, is there. You cannot say it doesn't refer to that, right? And then when your manuscript is rejected, well, you can, first of all, think about suicide. This is not a good idea. Buying a bottle of scotch or whiskey or wine is also not a good idea. You have to think that this happened to everybody. There are plenty of examples of Nobel Prize winners who got rejected their papers, even about the science of the Nobel Prize. So you have just to pause, relax, step back, and then, go back to the science, trying to be cool, look at the science, read the reviewers, why that was wrong. It may be that your paper was wrong, and then if there are some wrong conclusions, think again, what can I do better? Where is the mistake? How can I correct it? Move on, and then resubmit it to a new journal, or maybe to the same journal, if you think that you have changed substantially something in the paper. Nothing wrong with that. And then here we have the 10 tips, which summarize what we have discussed so far, but it is 11:30, which is when I have to stop, right? Because I added the 10 minutes that Maria Laura took from me. Okay, don't forgive anybody, even Maria Laura, 10 minutes taken away, 10 minutes given back. There's obviously a joke. And before the buffet, you like to ask some questions? Please go ahead and do it.
Thank you so much for your talk. I'd like to know if you select, for example, a fresh reviewer that has no so much experience, and this person don't do a deep reviewer as you'd like. You select a fourth opinion for that paper?
And I'll repeat, if he doesn't do a job properly, then?
No, if for example, he don't have enough experience to do a deep review from the paper. It's a person that's starting now to do this peer review. So you select a fourth opinion as editors.
I don't know, you select?
A fourth person, a fourth reviewer.
Another one, huh?
Yes.
Yeah, sure.
Okay.
If the reviews are not, so you keep on increasing the number of reviewers until you think you get a proper one. It can well be that one is enough, because it's very thorough one. If you're so lucky as an editor to get one of those, then you get, sometimes 2 pages review. Then maybe if you cannot find out more, then you can even stay with one. But it's possible that if you get these guys, saying, wonderful paper, publish as soon as possible, we cannot wait, then, but no comment, then those don't count. Maybe 10 of those, but you try to go with something else, right, which is more substantial. So that case that you indicated will fall in this category. So it will be a meager review, right, that you receive, and you feel that this is not so satisfactory. Because remember that the editors also give a judgment about the reviewer, right? So at the end, the reviewer is getting even a prize or a certificate, as I mentioned, but also every time the reviewer, you receive the reviewer, the editor is asked to say if the reviewer was in time, and then if the review was high, medium, or low level. Below average. At least this is in my journal, but I think it's common to everybody.
Thank you for the information provided. My question is that if, for example, a manuscript has been received by you and you understand that this is not related to the journal and it is related to another, do you suggest the author that, for example, you have to publish this in another journal, specifically by mentioning the name?
Yeah, we provide this service only within ACS journals, right? So when we say transfer to another journal, we have the possibility to click on various other ACS journals. It is not, we are not requested, it's not a must for us to do it, but if for the editor, based on his own experience, this is an obvious suggestion to give, why not? But I don't think there is a way to do it for journalists outside ACS, right, Jessica? There is a window, right? One of these things which opens up with many options, and I think I remember only ACS journals. So this is something that really the author should think about. Or maybe you can discuss it with many other people, but reading the guidelines is very important. Reading the guidelines, I like to stress what Maria Laura says, is not only when you publish a paper, but for example, when you apply for a grant, for a research, you submit your research project to some agency to be funded, right? Sometimes people does it without even reading the guidelines. And then, you send it to the wrong place, you ask too much or too low money, you make all kinds of strange mistakes and waste your time. So read the guidelines. That is in the guidelines.
Thank you, sir.
Yeah.
We'll take one final question and we can continue during the networking break with cafe and brioche in the lobby.
I'll be fast. Mine is more a curiosity than a question. And what was the biggest mistake you came across reviewing something? I mean, the huge mistake you found.
You mean in the science or?
Reviewing a manuscript.
And you found a scientific error?
A scientific and formal error, the biggest.
The most common error is violation of the second law of thermodynamics, creating energy or that is what sometimes happens. I don't know, my colleagues maybe have different experiences.